This next problem is on the laws of motion, right? And namely forces. So two forces, F1, which is equal to 50 newtons, and F2 is 30 newtons, are exerted on a mass of 30 kilograms below in the setup below. Geez. Find the acceleration of the mass. So this is the setup. Okay. This is a mass. This is 30 kilograms. Right. And F1 and F2 are exerted in this particular configuration. Right. This one is going to be uh, 50 newtons, and this one's going to be 30 newtons. Right. I'd like to find the acceleration of the mass. Right. So acceleration is basically a force times the distance. Acceleration is basically a vector, which means that has a magnitude and a direction. Right. So let's do it one at a time. Right. So let's label our axes first. This is the x direction, and this is the y direction. All right. Okay. And so we can write out what ax is equal to and ay needs to look like. Okay, these are the two directions of our vector. Okay, so let's get started on this. Okay, so remember the equation of motion, right? Newton's law basically says the force, okay, is equal to the mass times the acceleration. Right? Now the force, if we write it like this, the force consists of two components, right? The force in this case has a component along the x direction and the force along the y direction. So this force, F1, is going to be 50 newtons along the x hat direction. I'll write like this. Plus 30 newtons along the y hat direction. That's right, Newton right there. Okay. Now the acceleration is something I don't know yet, so let's just compute this thing out. Okay, so let's write down the force. This is going to be basically 50 x hat plus 30 y hat newtons is equal to the mass, which is 30 kilograms, right, times the acceleration, which is something I don't know yet. So acceleration is going to be ax along the x hat direction plus ay along the y hat direction. So it's going to be ax along the x hat direction plus ay along the y hat direction. Okay, so the rule is you follow the same things, the same hats. So the x hat goes to this x hat, y hat goes to this y hat. So this equation actually breaks down to two equations, one along the x direction, one along the y direction. So let's write down the x component first. Okay, so let's look at everything with an x hat. So this is going to be 50 newtons. Well, this is 50 is equal to 30, okay, times ax. Okay, and the y direction, this is going to be 30 is equal to 30 ay. That's the ay. All right. So what this means is that if I divide by 30 here, ay is equal to 1 meter per second square. Okay, this one is a little more complicated. All right, well, not much more complicated. This means x is equal to 50 divided by 30. So divide by 30 on both sides. All right, meters per second square, which is equal to 1.66 meters per second square. Perfect. All right, so I have the two components here. All right, so in fact, I'm actually done at this point. I can actually write down what the acceleration needs to look like. So acceleration is equal to, well, what's the ax is 1.66 in the x hat direction. Remember, there's a little vector here. Plus 1 in the y hat direction, meters per second square. Okay, now, a lot of times you may also be asked to compute what is the magnitude of the acceleration. Okay, so in that case, the magnitude a, so little a is equal to the magnitude of a, which is going to be equal to basically the square root of ax squared plus ay squared, right? So this is going to be basically the square root of 1.66 squared plus 1 squared, right? Which actually, if you compute this thing out, it happens to be 1.94 meters per second squared, right? So that might be another thing that could be asked, right? Now this is true as long as basically everything's along in the 90-degree direction. All right, well, hope that was helpful. All right,